attribute and there is going to be domain as well. So this is where the relational data model is going to be defined, that we will be creating the tables. Tables will have the name of the table. They will be having the column. They will be having the row, and they will be having the, with the other tables, they will be creating the relations also. So example, with this particular students table, if I will create another table which is known as a class, student class, right? Then how we are going to define the relation between the students and another table class is what is going to be known as the table relation. Okay. All right. Then when it comes to the relational data model, right, we categorize the relational data model with the help of a schema. Okay, now what is the schema is the thing which we need to understand. See, what happens is at a higher level, when we are creating the relational data models or basically any data model, right, we need to first design the structure. Structure is meaning how many tables we would be having, what are the name of those tables is going to be, how many columns they will have, what is the data type of those columns, how many rows can have, right? So that is where a schema is a logical representation of our database. Okay. Overall, when we talk about the schema, we will have a physical schema, we have a logical schema, and then we have a view schema. What is a view schema? First, let's talk about the view schema. A view schema is basically, why I'm talking about the view schema first instead of talking about the physical schema, because I wanted to understand from the user perspective. User perspective is you are the user who is going to look at the schema, okay, as an end user. So you should understand that what we are going to view, what we are going to see from our eyes, that's basically the view schema is. So as a part of the view schema, we will say that view schema can be defined as the design of the database at the view level, which generally describes the end user interactions with the database. So as I give you the example earlier, right? View schema is that particular load is that particular interaction where end users like you and me would be looking into the data based from our perspective. Example, let's say here at the physical, at the logical schema level, I'm calling a table student, okay, and it is having the 10 columns. But as a viewer, as an end user, I want to see only the two columns out of it, which can be student name and their project information. As another user, I want to see only the student ID and their marks. As the another user, I just want to see the student name and the corresponding class in which the student is studying. So that is where the view schema is basically that representation, which is going to be differ for the user who's, viewing that information. Okay, so that is where we have the last first schema on the top is a view schema. Then what we have is a logical schema. Okay, now what is a logical schema? The logical schema is basically that structure which is equivalent to the physical structure of a database. Meaning, let's say you have defined that there is going to be you're dealing with the let's say retail information. Okay, in a retail information, you will be having the products, you will be having the vendors who is going to supply the product, you will be having the customers, you will be having the employees, you will be having the physical stores. Okay, you will be having other different set of informations with you, right? Now, how you're going to logically bind all this information together, that becomes your logical schema. Example, in this logical structure, you will be having at a high level defined that which field is going to be linked into which table and which table is linked to other table with the help of the physical relation. Either it is going to be a primary key relation or either it is going to be a foreign key relation. So that information, which is going to be defined logically as a part of the schema, it goes into the category of the logical schema. Okay. And finally, what we have is the physical schema. Physical schema is basically that representation of the structure, that queries which you are going to actually create on the database and see the information with you. So let's say that you have created a database into your Oracle. So when you have to create a database into the Oracle, you cannot create it if you're not aware about the logical structure. So before you convert the logical structure to the physical structure, where you will be having all the tables with their accurate data types, their column names, that basically becomes your physical schema, where all the tables, their table names, their data type, physical relationships, everything is available, and finally it is being created at the database level. So how the data is going to stored into the different tables, how the information is going to be available into the different databases is going to be known as the physical schema, right? So it's very important in a relational data model that the schema structures has been defined correctly, and either it is a logical schema, either it is a physical schema, or either it's a view schema, has to be defined in a certain manner, and the different tools is going to be used for the schema. All right. Now, finally, when we are continuing, here we will understand what is the differences between a physical and a logical database schema what we have. So as we say, physical database schema, it's basically not going to include the attributes. However, the logical database schema is going to include the attributes. Physical database schema will have a concept of the primary and the secondary key. So what is a primary key is basically, and what before that, we talk about the columns, right? Attributes is basically the columns. Okay, when we talk about the physical database design, we are more focusing on the structure of the tables and how it is going to have the relationship between the different tables. However, in the logical structure, we talk about the each and every column and their information as well. When it comes to the primary key and the foreign key definition, that is going to be available at the physical database schema level. When it comes to the logical schema, we are going to talk about the primary and the foreign key. Also, that is the similar feature which is there between into the physical and the logical schema. Physical schema contains only the table name. Logical schema contains the table and the column names both. Physical database schemas contains the column names and their data types. Logical schema contains the column names, nor contains their data types. So that's where the difference comes when it comes to the physical and the logical schema. And the final structure which is going to be available at any database level is going to be the physical structure. Right, so that's we have now. What we will be doing is we will be moving towards a hands-on exercise where we will be showcasing a quick demonstration and help you and understand that when you have to design a physical schema or when you have to design a logical schema, how it is going to be done. So for this particular purpose, what we will be doing is we will be using an online tool platform which is known as the DB designer. Okay, and keeping that in mind, we will be designing our structure. So I'm sharing a link with you, everyone, which is having a lab guide link with you. Okay, you need to follow the same lab guide to perform the particular exercise. However, it's going to be available later on your session also. Okay, please open this link on your end as well, and let's follow the steps with us. Okay, so as we are discussing about the databases, we are going to perform a quick exercise on the database designing as well. So I would request everyone to please log in into the database online designer tool. The link has been given here. Log in as a guest, and we are going to start designing our databases. All right. So if you will see on my screen now, what you can see here is here we have on the right hand side a schema explorer is there. This is basically a guest template is available with us. If we want to make any changes to our template, we can explore this, or we will be creating a new one as well. All right. So as we discussed about the database schemas, right? That's where we will be following and understanding that what we do. So first we said a database schema is what is a logical representation of the data where we are going to store the data. Okay, then here when we create a database schema, right, what we include, we are going to include tables, we are going to include columns, we are going to include the relationships with the primary key and the foreign key, right? So to understand this, how the schema is going to get created, how the schema is going to get generated. Now, there are different tools are available in today's time. There are the ER data model, there are, ER Studio. There are multiple tools are available using which you can, create the schema. But we are using this online editor app DB designer where everyone can perform directly from their browser. So first, as the process of designing the schema in this tool, we will be creating a new schema here. We will be providing a name to it. I would put it as the data underscore schema. Now, there are the multiple options based on which you can create the schema. Example, if you choose the schema as a generic, then it's going to allow the SQL which is going to run for all the databases. But if you will choose a schema which is going to be database specific, then the database types, then the structures, okay, the syntaxes is going to be only applicable for the Oracle. So at this point of time, as we have not listed or specified our database, we are keeping the database schema as a generic, and we are going to click on this create new schema button. Now, once we click on this create new schema button, we will see that a blank screen is being there. Okay. At this particular point of time, we need to understand that how we are going to insert the field. And why we are performing this is because when we are going to create a structure, right? Before we are going to create the structure, okay, you're not able to download the file. Let me check a cheat once. Hold on for a second. Please check it now. Or yeah. All right. So as a part of the databases, when we are going to design, a database will have a table. So you will not really start using the SQL or any programming language to just, start writing the queries and design the database. You need to follow a particular method of schema designing. So that is where to design your schema, to design your set of tables which you have, how they are going to have the different, relationships and everything. We are performing this exercise of the schema design. So first, as I said, we are going to have the multiple tables. Currently, this table is known as untitled, which we can see. Okay, here we can rename this particular table, and I'm going to rename this particular table as the user. If we want to put any comment here, we can put a comment and say, now the next task which we have is we need to insert a particular fields into the table. So as a part of the field, we are going to call this as a user underscore ID. Now, as I said, right, I'm going to define the different data types. We are going to choose the data type as an integer. Now we are choosing the concept of a primary key. What is a primary key is basically, so what happens is, in a database table, we can make one column as a primary key, which is going to have the unique values, which cannot have any null values or empty values. Okay. And which is going to be uniquely define the data row in the table. Okay. So consider that we will have created the user ID as the unique value. So in this case, when any user we are going to create in this table, we will make sure that they will have the different unique ID as a user ID. Okay, so this becomes our user ID, which we are going to call as the unique ID. So once this is done, then the next thing which we are going to do is we are going to click on the save button. So we'll have a table now with the user as a table, and it is going to have a user ID as the column name. And here you can see that as a part of the schema explorer, you can see this is the schema name, this is the table name, and this is the column name which you have. Then we would be adding the another set of columns also. The next column which we want to add here is I'm going to call as the media ID. So media underscore ID. Same the database we are table we are choosing as the as an integer. The column we are choosing as an integer. The reason why we are choosing this as an integer, because we want to store only the numeric data into this, right? And again, for the same, we are going to make this as a primary key. Now, as I said, right, in one table, we cannot have two primary keys, but we can have two fields combined together and make them as the one primary key. That is what we are using here. In case if you want to edit it later, we can do that as well. So now when we are adding, let's say we will be adding one more column, which we are calling as a name. Now name cannot be an integer, so we are going to change the data type to varchar. Why varchar? Because when we deal with the databases, right, the database types is not text. Okay, this is going to be known as a varchar or varchar2. So that is where we are considering this as a varchar. Now, as this is a string data, right? So string is something which can have an infinite value basically. But we want to store the data up to the length of 255. So that is where we are specifying the size here as a 255. If you want the data to be stored of less length or more length, then you can adjust the size of the column accordingly. Then now here, once this table has been created, we are going to create a one more table, and this table we are going to call it as the media table. Here in this table, we are going to add the fields, which is going to be ID. ID I'm going to keep as a field of integer, that we will be having the integer values. And this I'm going to define as a foreign key to this particular table of the media ID here. So the reference table would be user and the column name is going to be media. Now, as I said, right, when it comes to the relational data modeling, we would be using a concept of primary key and foreign key. Primary key is basically that column which cannot have a null value, which cannot have a duplicate value. Okay. However, on the other hand side, foreign key is that column which is going to be pointing to the primary key of the parent table, right? Here we will be using the concept of parent and child, meaning let's say a child cannot born until unless they have a parent. So similarly, a foreign key cannot be there until unless it is having a parent table. So in this case, what I'm saying is the ID value of the media table is going to be driven from this media ID from the user table itself. So here you can see this is acting as a foreign key now from the user table. Okay, this is acting as a foreign key into the user table. So media table is independent, which is a parent table here. So any new media is going to get generated here, and post that the value is going to be linked to the user table. Right? So a relationship has been created. This is our known as the primary key foreign key relationship. Okay. We're going to add another column here, which we are going to call it as the path patch. Okay. This is going to be specifying as a varchar. Same data length we are going to keep as 255. We are going to save this. Oh, sorry. This is not going to be foreign key. Please make sure that you don't add that as a foreign key. Then we are going to have one more column here, which we are calling as our file type varchar 255. Uncheck this foreign key option and you will have the third field added into your table. So you can see now, and then the last one which we are going to add here is going to be file size. And as it is a size, I'm going to keep the data type as decimal. So see what happens is when it comes to the data types, right? I personally define the data types as a number, string and the date, because decimal is also falls into the category of the numeric data type. Yes, when you have to further bifurcate, it can be number, it can be integer, decimal, etc. But a higher level, it can be number, it can be a your string, and it can be a date. But in this case, as we want the file size to be stored the numeric values also, we are choosing the data type as a decimal. Right, and actually this is gonna be corrected. This is the path updatedly, and this would be your files. We are going to add one more table here, and we are going to call this table as the project table. And in this project table, we will be adding, starting with the field called ID, which is going to be of integer data type, and is going to be the primary key into this table. Save it and save the table name as well. Now, here further, we are going to add one more field, which we are going to call as the user ID, because each user is linked to a particular project. This is going to be a foreign key to the user table on the user ID column, and this is how the structure is going to look. So you can see the user table is going to be act as a linkage between the media and the project table. So now, before a project is going to get created, a user has to be there, and before a user is being created, a media has to be there. So that is how this flow is going to look. Right now, considering the project table, we are adding one more field here, which we are going to call as the manager. As manager is a name, we are going to take it as a varchar of 255. And this the third field we have. So here, if you will see, with the help of this particular exercise, we can see if we have to create a relational data model where we'll be having the multiple set of tables, we can follow this particular method where we are starting with the first table, then we are defining the relationships of the primary key and foreign key with the other set of the tables which we have. So this gives you the fair understanding that when you have to design your physical models, what would be your starting point, how you're going to choose the accurate data type, and based on that accurate data type, how you're going to define the relationship further. So either you will choose any set of tools which you have, or either you will choose this tool. This the methodology of designing the structure would remain same. Right, so now once this is done, if you want, you can save this, okay, and you can email it to yourself. Let's say I'm gonna email this to myself on my personal, on my official email ID, and before that we need to create an account. Currently, as we are signing up as a guest, we will not. So if you want, you can create a new account and use it, or what you have the option to import. If you have any existing one, you can import it this way, or you want, you can export this in term of Excel and SQL. You can import it in term of PDF as well, or image. However, for all the options, you need to make sure that you have signed up for an account before, right? So that's where we would stand that how a physical data model is going to get created, how a relational data model is going to get created, and as a starting point for any data model which you have as a starting point of your information, how it is going to be, right? So that's all.